At this point, Ed Pieret, our vice president, past and present and future, and has generously offered to give us a presentation based upon material from his Night Sky Network and NASA and so forth pertaining to extraterrestrial life, if I remember
Yep.
correctly. So Ed, it's I'll hand it over to you.
Okay.
Notice I said extraterrestrial life, not intelligence.
Yes. Okay, I'm going to share this and let me
Yeah,
go up
I'm
a few-
proud to be a microorganism.
Yes. Okay, I got asked to talk about life in the universe. Now I have one slide to show you everything we know about life in the universe. For sure.
Nothing.
Nothing. So let's sit around and see what we can
Well,
say.
thank you all for coming.
Now we like to imagine aliens exist in movies and television and stuff like that, and they're kind of fun to look at. I mean, these guys look like have a bad scar on their forehead.
Digital Chris.
Guys, yeah, guys like this. How about him?
Good gravy.
He's
It's my old college roommate.
yeah. Some of them are kind of funny.
I gotta get
Some
over.
are really scary. I mean, the original Alien film, I think, is the scariest film I've ever seen.
Yeah.
You never saw it.
I was trying to climb under the sofa when I saw that.
Yeah. You never did see the full size one. But,
No, this is true.
yeah. But most movie aliens look like men in rubber suits. For a good reason. They are men in rubber suits. They almost all have 2 eyes, 1 nose, 1 mouth, 2 arms, and 2 legs. No reason we think an alien would, but it does. And the faces are human enough to be frightening. Something called the uncanny valley. If something looks close to human, we find it more disturbing than if it doesn't.
That isn't valet, is it? VALET?
No. Now, do aliens exist? Yes, I think so. I mean, basically, look at how many stars there are. If you just picture standing on the beach, picking up a handful of sand, you've got maybe 4,000 or 5,000 grains of sand. Now think of all the sand on the beach and all the sand on all the beaches in the world. And there's about 100,000 or 1,000,000 or 1,000 or something like that stars per grain of sand. Many more than are grains of sand. There's a lot of stars out there. So no matter how rare life is and alien life is, it's got to be out there someplace. There's just too many places for it to show up. Of course, we don't know if any's close enough, so we'll ever know about it. And it's best to understand life on Earth to try to understand what alien life might look like. First off, visitors. Are they here? I don't think so. First off, our government can't keep a secret. Heck, they couldn't even keep a nasty affair the president had secret. So they could not, for 50 or 100 years or whatever, keeps alien visitors secret. And the second thing is, us guys don't tend to see UFOs much.
That's true, because we usually know what they are.
You usually know what we're looking at. So what are some of the things that cause it? This is a meteor, never hit the Earth. It bounced off the atmosphere. But it's one possible UFO. I saw something flying through the sky very fast. What was it? How about this? Miniature clouds.
Particular cloud. Yeah.
That is a cloud. It certainly could have convinced you it was a UFO or another one.
Yep.
Also, there's something called ball lightning. It's very rare. It has been recreated in the lab. It does exist. This is a picture is believed to be ball lightning.
Right.
A ball of charge around an electrical storm that just floats around slowly. So, and my number one,
Venus.
number one cause of UFOs is Venus. Because if you see it just over the mountains, you're driving along, it looks like something moving. And if it's low, it's going to change color because of the atmosphere. And you're going to see a UFO flying along the mountain, going at the same speed you are. Anyhow, and just recently,
Ed, could I interject something?
yeah,
When I was a boy and just joined the society, there was an old gentleman by the name of Fred Jacobs, who was a retired United Airlines DC-6 pilot. And he described an instance when he was in the Navy. They were out at sea, and all of a sudden there was a report of an attacking Japanese aircraft. And so the anti-aircraft guns swung into action and started firing almost vertically, almost straight up, and shells were falling down all around the boat into the water and so forth. And then finally, suddenly the navigator burst out of the cabin and said, "Wait a minute! Stop! Everybody, stop! That's the planet Venus."
Yeah. Now, just recently in the news, there's been that the Pentagon's about to release a report, what they call unidentified aerial phenomena,
Right.
UFOs. There's strange things. I mean, this took up pages in the New York Times and stuff, which is ridiculous. Sometimes pilots see strange things. Most of them are optical effects, refractions, things like that. They can be rocket launchers, space debris, re-entering the meteors can appear. There's also atmospheric disturbances like auroras and sprites, which are very rare and hard to see. Auras and sprites. Any of these can be mistaken. I'm going to be interested to see what the Pentagon's report says, but I haven't seen anything in any news reports that make me think at all it's a UFO or an alien.
Yeah. Ed, could I just ask, how do you define a sprite?
Oh, it's
lightning going from the earth up into the sky?
Yeah, it's a high altitude phenomena where they see these mostly red lights going way up high in the atmosphere.
Oh, okay.
Above clouds and above the aurora.
A solar phenomenon?
Yeah. Huh?
A solar phenomenon?
It's another electrical phenomenon, another phenomena of glowing atoms. But
Yeah.
it's not, it's not an UFO.
Okay.
And of course, remember Carl Sagan, extraordinary claims require extraordinary evidence. So before you let somebody tell you, hey, that's got to be a UFO because nobody else knows what it is, that doesn't prove it's a UFO, it just proves nobody knows what it is. Aliens, anyhow. What do we know for sure about them? Nothing. But alien life, nothing. And how many examples of alien life do we have? None. So, what do aliens really look like? We probably won't know till we see one. Probably not much like an Earth person. And probably not much like us. So what do we know about life? We have one example, Earth. By studying life on Earth, we can begin to understand how we might find life outside. So let's take a quick look. First off, All life on Earth uses DNA. It's a self-replicating material which exists on all organisms on the Earth. It's a software program that defines us. And so what we also know about life is it arose very soon after Earth cooled. Now, the next two claims are a little more interesting. All life on Earth has a common ancestor, and life only arose once. Why do we say that? Well, DNA uses 4 base pairs only. There are many more chemicals that could become part of a base of DNA. All the amino acids used by life on Earth are left-handed. In nature, there are an equal number of left-handed and right-handed, but we only use one kind. Sugars, on the other hand, are all right-handed. Again, in nature, both exist in equal amounts, but no life on Earth uses a left-handed sugar. And of course, we have no fossil evidence of any life except ours. Let's look at life. Here's our close buddy. Could be a cousin. How about this guy? This guy is great. That's a water bear, tardigrade. They actually can live between 1 degree Kelvin, 458 degrees below 0 Fahrenheit, or up to 272 degrees, or I'm sorry, up to 300 degrees Fahrenheit above boiling water. Put them in it, they'll be fine. They can take pressure about 6 times greater than the highest pressure in the bottom of the ocean trenches. They can survive radiation hundreds of times stronger than that would be lethal for humans, and they can live in the vacuum of space. And we have some of them in the space. They're microscopic, but they're probably the toughest animal in existence. Here's another relative. This guy has got half the DNA, half of his DNA is shared with us. So it's worth celebrating. He's our close cousin. So let's look a little closer at life on Earth. Now, in a presentation in a school, I would normally have this chart up on a wall, and it's about a 5-foot chart. And I want you to think about it. It shows a human figure down below with their arms spread to try to explain the time frame of Earth. Now, what I'm going to do is make this bigger so we can see it and start over here. If you spread your arms out, at the end of your left arm is the beginning of the Earth. Moving along, the moon formed and so on about your wrist. The first life appeared about halfway up your lower arm. That's where life first showed up on Earth. Now we get all the way over here to just about your right ear. That's where the first multicellular animals showed up on Earth. And meanwhile, the Earth itself, geologic, has been changing. If we continue further, the first animal appeared about at your wrist on your right arm. The first land animal just about at the base of your thumb. And I'm going to have to move this out of the way. The first dinosaurs appeared right about between your palm and the whole age of dinosaurs and the second joint of your fingers. Man, just out of the tip of the fingers appeared, and modern civilization could be wiped out with a single pass of a nail file. That's how long we've been here. So human ancestors been around for about 2/100%, or let me find what I'm looking for here. 200% or 1/50th of 1%. Modern humans have been around for 1/250th of 1%. And civilization has been here for 1/5,000th of 1% of the age of the Earth. Hadn't been here very long. Suppose the asteroid hadn't hit. We might look like this. Or who knows, we might look like this. Okay, so life arose soon after the Earth cooled. Only arose once. For 3/4 of the time life was on Earth, it was single-celled. Intelligent civilized life only exists on Earth for a very short time. And wherever there is liquid water on Earth, there is life. In Antarctica, and of course, there's also life under the ice and the water. Down here, at a temperature well above the boiling temperature of water, deep caves, there's all sorts of life. They've lost their eyes because they're not needed anymore, but there's lots of life living in deep caves. And here is a salt evaporator where they let seawater evaporate into salt. It is very, very salty, and that's what's causing these various colors. Are different algae living in salt that would kill almost any other animal.
Could I suggest whoever's sneezing maybe want to mute the microphone?
Yeah, and this is a spring in Yellowstone, the Grand Prismatic Spring. These are the colors are caused by various microorganisms that like to live in various temperatures of water. This is very hot water, boiling water coming up in the spring. So life on Earth lives almost every place, but we are looking now for life in our solar system. The reason we're looking in our solar system is we can't look anyplace else effectively. We would need much faster ships to get to stars. Our current ships would take 70,000 years to make it. So in our solar system, we know that at least on Earth, all life forms require liquid water, an energy source, and a supply of carbon. Every place those exist on Earth, we have life. So let's look. In the solar system, the only planet seems capable is Mars. And then there's a possibility in several moons. So what do we know about Mars? Mars once had oceans. There's a lot of water ice, a lot of water in the ice caps. There's a mysterious source of methane that could be geological, but we think Mars is geologically dead, or it could be life. And there may still be liquid water underground. So this is what Mars looks like today and what it looked like billions of years ago, when the sun was warmer and it was closer. course, sometimes we got a little life, people getting very concerned about life, like this face on Mars, but it just turned out to be a little hill, or a meteor that came from Mars had what looks like microorganisms, fossils in it, though that was pretty well debunked with because there are other processes that could have caused those. Now, there's also several moons that might have life on them. 3 of Jupiter's Galilean moons and 2 of Saturn's moons. These moons are so close to the giant planets that the tidal forces are heating them up inside. So we think that Europa has an ocean under it, as does Ganymede, and as does Callisto. They all look like they could have oceans under them. Any of these oceans could have life. Remember, life on Earth, life in the bottom of our oceans does not require sunlight. It only requires the energy of the volcanic energy, and there'd be a lot of energy from the tidal flexing. Another surprise in Saturn was Enceladus. In Enceladus, when Cassini came by, they saw this stuff coming out of it. Testing it, they found out that's water. These are geysers. Of course, they're ice by the time they hit space, but the only way there could be a geyser if there was liquid water under the ice in Enceladus. There's also Titan. If you look close at Titan, gee, it looks like it could be the coast of any place on Earth. Here's liquid, look like a shoreline. However, the liquid is methane and ethane, not water. But it is possible there's a life series going on using that. So what if we find life, even single-cellular life, in our solar system? It would probably only be single cell, but it would either be the same or different than Earth life. That's the only possibilities. That's profound. If it's the same as Earth life, then we have a single source of life in the solar system. If it's different, it means that life has arose more than once in a single solar system. It must be all over the place. So either would be a very significant finding. Planets, just saying there are a lot of alien planets we know about, 4,401 right now, we're sure of, 3,000 solar systems. So one other thing we're looking at, just mentioned SETI. I think just about everybody in our thing is aware of SETI. The idea that an alien intelligence would probably use radio to communicate, and we could listen in on their communications. Is that proven? No. But it's interesting. It would be profound if we ever did hear it. But there's a problem there. And I think these ants that have finally accomplished the ability to think shows what the problem is. Two ants are talking. We searched dozens of these floor tiles for several common types of pheromones. If there were intelligent life up there, we would have seen its message by now. Of course, they don't know what they're looking for. Maybe we don't know what we're looking for. So let's finish up talking a little bit about something called the Fermi paradox. Enrico Fermi was a brilliant scientist. He built the first atomic reactor. He was a very significant contributor to the Manhattan Project. He did a lot at Los Alamos. What happened was he did some calculations one time when he was out to lunch with some of the other scientists, including Teller and a few others. And he said, we should be being visited by aliens. Where are they? Let me try to explain his calculation. Let's just look at human beings and what we're going to do probably in the future. Let's say that it takes us 500 years into the future. Remember, that is the same distance of time as from the Renaissance, the beginning of the Renaissance. In that much time, we might be able to establish 2 colonies on other planets. It's an incredibly long amount of time. And let's say in the next 500 years, each of those colonies managed to establish 2 colonies. So in about 2,000 years, we'd have 16 colonies. In 3,500 years, we'd have 128 colonies. In 5,000 years, we'd be up to 1,024 colonies. And in only about 3.75 million years, we would have filled the galaxy with colonies. Now, admittedly, in 3.75 years, we wouldn't look like humans. We wouldn't all look the same or anything close to the same. But the galaxy would be filled. That is an incredibly short amount of time as far as the galaxy's life. So what it's saying is, and what Fermi said is, if any civilization has been around our galaxy for several million years, they should have colonized the entire galaxy by now. We should have been visited many times over. But we have no evidence, nor have we found any firm alien artifacts on life. Where are they? Well, several solutions have been proposed. First off, we're alone and always have been alone. Life only happened on Earth and never happened anyplace else in this vast universe. Doesn't seem likely, but it's possible. We could say advanced civilizations always destroy themselves at a certain point. We certainly have the capability to destroy ourselves. Are we going to be wise enough not to, in the next 500 years, wipe ourselves out? Or maybe nature automatically eradicates civilizations, global warming, things like that. Maybe it just knocks back civilizations so we never get to the point where we can build interstellar spaceships. Or maybe the galaxy has never been colonized. It is hard. You're probably going to need multi-generational spaceships where people live and die on the trip. And the people who land are many generations later than the people who left. Or maybe advanced civilizations just decide there's no need to colonize. We don't want to. We got our population under control. We aren't using up our resources. Why spend the effort? We could say civilizations colonized the galaxy. We just don't know it. They aren't telling us. The prime directive, or Earth is a zoo idea. Or we can't tell they're there. They're there, but they are so alien that we don't recognize. Or maybe we have evidence, but the government won't tell us. As I said, I don't believe that. And finally, we are there, they are here, and we are them. Sort of what I call the Star Trek. Everybody looks human because it's all the same species. The only thing that makes me think that's not accurate is because we know step by step how the human body developed. It's not like somebody just dropped a fully formed human on Earth. So anyhow, those are some of the ideas. And one final thought when we encounter an alien is Arthur C. Clarke's quote, "Any sufficiently advanced technology is indistinguishable from magic."
Mhm.
Just think what Isaac Newton would have thought if we could have showed him a cell phone. I can talk to anybody in the world on this. I can do a calculation in a blink of an eye that would take hours by hand. I can listen to music, look at movies. This is magic. It would have been magic 30 years ago. So anyhow, matter of fact, Isaac Newton would probably call the garden had us burned as a witch. So it's basically what I have. We got any questions?
Very good.
Yeah? Karen?
Oh, no, I'm saying it was very good.
Very good.
Well, by the way, the actual slides, obviously, there's a video and the video will be posted, but the actual slides are on my website. If you'd like to look at them, they're on, it's astronomered.com, one word. Pretty neat URL, I think, but astronomered.com. And the slides are out there. So I'm gonna.
That was very
try
nicely done.
to, if I can. There we go. I'm going to stop my sharing so I can see everybody.
That was very nicely done, Ed. Very entertaining and insightful.
Okay. Mary Ann.
Okay, so what I heard you say is that we believe that other stars may have planets, and our conception of life would not be able to live on a star. It would have to live in planets. Is that kind of a summation?
Well, any life we know about.
We already know there are planets around other stars.
Yeah, we know there are planets around other stars. Matter of fact, we find planets around most other stars.
Okay.
We think that more than half of them have planets, but just based upon how we found them and how likely we are to find them. But the only thing we can think of on life is think of life like ours. Now, is it possible there's other forms of life and other forms of intelligence? Of course, but we can't even imagine them. So what we want to do is think about life and look for a life that's something like our life.
Yeah,
You
it's,
can-
And the water bear you showed, because I've never seen that before, tardigrade. So that's
Yeah.
some sort of.
Oh, that's fun. Look them up.
Well,
Actually,
yeah, I plan on it. That's why I wrote it down. But it was, I think I counted 8 legs.
I
yeah.
did too.
Well, they're
Mary Ann.
microscopic. They're microscopic. Remember,
Yeah,
you're going to need a
yeah.
microscope to see them.
Okay.
In fact, there's some on the space station right now.
Spider family.
They just took them up for some tests.
They're part of the spider family?
Yeah, well, they're, matter of fact, I'm told that if you want to see them, if you have a microscope, all you have to do is get some moss. The best idea is to let it really dry out so it
Mhm.
kills everything else in it.
Okay.
then put it in the water and take a drop of the water and put it under a microscope.
So
Very
spiders
cool.
have
Yes,
8
these
legs.
guys will pop right back up.
Yay.
Spiders have 8 legs. That's why Karen mentions it's a spider.
Good point. Yeah. Okay. Thanks. No, great talk.
Arachnoids,
I
right?
always like your talks, Ed, because they're on a level I can understand.
So it's an interesting thing that we need to look for life that we can recognize, maybe life like us. But
Mhm.
actually, when you look at the structure of the solar system, it was always assumed that when we found planets around other stars, solar system formation would more or less parallel our own. That when we found planets around other stars, there would be similar number of planets and at similar distances from their stars. And it turns out to be completely incorrect.
Yeah.
Our solar system appears to be unique in our experience.
Mhm.
The almost every other solar system where you find giant planets, they're in very close to their suns. They're called hot Jupiters. Almost every planet that's mentioned in the news as a grand new discovery is called a super Earth, a planet in size of roughly 2 to 10 times the Earth's mass. We don't have any super Earths in this solar system.
Yeah.
So everything is different, and the solar system is larger. Ours is in terms of the distances between the planets that appears to be typical in
Sure.
other solar systems that have been
Well,
discovered.
yeah, part of that, though, Mike, is because the way we're looking.
Yeah, I understand.
We would have a lot of trouble seeing a solar system like ours.
Yeah,
Because even Mercury, we might spot Mercury because it's got about a 3-month thing. Earth, we'd have to watch that one star for 3 years to see Earth, because you've got to see it pass in front 3 times, or pull the star off 3 times to
Yeah.
know it's not some other effect. So it would take us 3 years, and to see Jupiter, well, to see Saturn, it would take us 900 years of observing. So our observing techniques are biased toward planets that are close to the sun. Our way of finding planets is biased towards planets close to the sun.
but the great difference is that the giant planets
Mhm.
in those solar systems are all much closer to their
Yeah.
prime.
Yeah, because we can see a giant planet much easier than we can see a small planet.
But we don't have any close to our sun.
Yeah. Yeah. In fact, it did blow apart a lot of theories about planet formation, which had to do with the gases migrating out further and the rocks and stuff migrating in further because of gravity. And there was all this buildup of why the outer planets are gas and the inner planets are rocky. I mean, what we've seen looking at other solar systems blows all that apart. There is no reason, because there's no need for them to be that way.
So given the fact that the solar systems are in no way similar to our own, it's probably a reasonable supposition that life may be in no way similar to our own.
Yep. Yes. And if life's no way similar, we not even sure how to recognize it as being life.
And we certainly would have nothing in common with it.
Mhm. Yeah. I mean, how do you what do you say something? How do you say something's alive? If I mix baking soda and vinegar, it bubbles, and the bubbles it gives off is carbon dioxide. I'd say, hey, something's that they're breathing and giving off carbon dioxide.
But not necessarily.
Yeah, it's not alive. What test do we have to say for sure this is life? There really isn't any. We don't know. I mean, we know that life has to eat, If it's not consuming something, it's not life. It reproduces. But it may take a very long time to figure out that anything's reproducing or doing it. And there are chemicals that reproduce and chemicals that absorb other chemicals. So, yeah.
Oxygen? No.
Anyway, well, if there are no more questions, I think we probably are at time to ask Mike about a star party.